Last week, we got an introduction to databases and to the structured query language, or SQL, by learning how to use SQLite. Although we learned how to create databases, we never actually learned how to query those databases, which is arguably the most important aspect of a query language. Assuming that we can figure out how to extract data out of a SQLite database, how can we then export that data either to an external file that's saved to our hard drive or into memory where we can access that data using Julia? Well, let's find out. Welcome to Julia for Talented Amateurs, where I make wholesome Julia tutorials for talented amateurs everywhere. I am your host, the Dabbling Doggo.
I dabble.
Today, we'll learn the basics of the SQLite query commands, which is how we can filter that data to find the specific information that we're looking for. As our data source, we'll be using something called the Chinook database, which is like the Hello World for learning about databases. We'll start by learning the essential query commands, and then we'll learn how to export our queries to various file formats, as well as how to load that data into memory where Julia can access it. Finally, we'll create a custom GUI using the gtk.jl package that we will use to display our queried data. For this tutorial, knowledge of Julia and VS Code is required. I'm assuming that you've already watched last week's Database 101 tutorial. You'll need the VS Code extension for SQLite, and in addition, you'll need to be familiar with the gtk.jl package. Okay, let's get started. Let's start by opening VS Code. In the Explorer panel, create a new folder for this tutorial. Next, we need to download the Chinook database for SQLite, which is a free database that is used for educational and testing purposes. You can download it by clicking on the link in the description below. Be sure to save the file in your tutorial directory. Once you download the file, make sure that it has a .SQLite file extension. There are several different versions of the Chinook database available in different file formats. We're only interested in the SQLite version. According to the GitHub page where this database is hosted, the Chinook data model represents a digital media store, including tables for artists, albums, media tracks, invoices, and customers. The media-related data is based on real data, but the customer, employee, and sales data was created using fictitious and/or randomly generated information. In VS Code, go to View, Command Palette, and search for SQLite Open Database, and select the Chinook_SQLite.SQLite file. Once you do that, you should see the database information appear at the bottom of your Explorer panel. Unlike the simple databases that we created last week that contained a single table, you'll see that the Chinook database contains multiple tables. You can twirl down on the table names to see the column names and data types. There are a few data types that we did not discuss last week. For example, n variable character, date time, and numeric. Some of these data types are used in different database languages and are not necessarily relevant to SQLite. For example, n variable character 160 may be used in other database languages to indicate a text data type with a variable column width up to 160 bytes in size. But in SQLite, all column sizes are variable in width, so this n variable character data type is ignored by SQLite, and SQLite converts it to a text data type. Likewise, there is no datetime data type in SQLite, since SQLite does not have a storage class set aside for storing dates and/or times. Instead, SQLite uses built-in date and time functions to determine the appropriate format for that data. Numeric is an example of what SQLite calls a type affinity. When data is inserted into a numeric column, SQLite will try to convert it into the most appropriate data type. You can also click on the arrow next to the table name to see the contents of those tables. As you can see, these are all independent tables, but they are related to each other in some way. Now that you have a feel for how this database is organized, let's learn how to query this database to find the information that we're interested in. In order to start a new query, click on the New Query icon next to the database name. A new file should appear with --SQLite at the top. -- indicates a comment in the SQL language. Save this file with a .sql file extension. You can use this file to enter and execute SQLite commands. It's basically a text file, and you can comment lines out by using Ctrl//, just like you would with any other language in VS Code. In the SQLite Explorer, click on the arrow next to the genre table. When the table appears, click on the down arrow next to SQL. The code that appears is the SQLite query statement that is being used to display this table. The select statement is the main query command, so you'll be using it a lot to find the information that you need. The asterisk, or star, is the wildcard character for all. The from clause is used to tell SQLite which table to use. The semicolon at the end indicates the end of a statement. Sometimes the code in SQLite will work without the semicolon, and sometimes it won't. So, as a best practice, you should always end your statements with a semicolon. You can type that code in yourself in your .sql file. Right-click in your .sql file and select Run Query. The first time you try to use Run Query, VS Code will ask you to select the database that you want to use. Select the Chinook_SQLite.SQLite database. Once you run the query, you should see the same table that you saw when you clicked on the arrow next to the genre table. Copy and paste this code several times and change the table name to see some of the other tables. Now, right-click in the file again and select Run Query. At first, nothing appears to have changed, but if you scroll down, you should see all of the tables that you have queried. If you click on the down arrow next to SQL for each of the tables, you should see your SQLite statement for each query. Okay, so now we know how to select everything from a table. What if we only want to see a few columns from a table? Click on the arrow next to the customer table. As you can see, it has a lot of columns. If you only want to see the first name, last name, and email columns, then you can list them individually, separated by commas, rather than using the star. So that was simple. Now, what if you're trying to find a customer and you want to see this customer list sorted alphabetically by first name? To sort a query, use the Order By clause. Use the ASC keyword for ascending, and use the DESC keyword for descending. So that's pretty easy. Now, what if you want to use a search condition to filter your data? Use the Where clause to filter your query. Here, the query will only return a list from the album table where the artist ID is equal to 1. You can also filter data by using comparison operators. Alternatively, you can filter data using logical operators. So that's not too bad. Now, what if you have a long list and you want to limit the number of rows to display? For example, if you click on the arrow next to the track table, you'll see that it contains approximately 3,500 rows. You can limit the number of rows to display by using the limit clause. Okay, now what if you only have a fuzzy idea of what you're looking for? Is there a way to search using wildcards? For example, let's say you're looking for the name of a song and you only know that it starts with the letter B, as in boy. You can use the like operator to query your data based on partial information. Note that this search is case insensitive. Now, what if you're trying to find a song that has the word dog in it? How do you search for that? So, those are the basics of performing queries in SQLite. There are a lot more options, but this should be enough to get you started. One last topic that we need to cover is how to join tables. One of the key concepts that is fundamental to relational databases is that you can store data in separate tables, and then you can combine them if they're related in some way. This way, rather than having one massive table that contains all of your data, you can have separate, smaller tables that contain only the data that is relevant for that table. This makes it easier to maintain and makes it easier to scale up. For example, the track table contains a lot of information, but it doesn't contain all of the information stored in the database. For example, the track table has a column for album ID, but not the album name. It also contains a column for genre ID, but not a column for the genre name. The album names and genre names are stored in separate tables where it's easier to maintain. But when querying the data, it would be nice to see all of that information in one place so that it's easier to understand. This is where you use the inner join clause. If you scroll all the way to the right, you'll see that using the inner join clause here added the name of the artist to the album table. This statement is saying that you want to join the album table and the artist table, and that you want SQLite to join the table on the artist ID column, which is contained in both tables. Let's take a look at another example. Again, if you scroll all the way to the right, you'll see that the album title information has been added to the track table. Since there are so many columns here, our query is becoming harder to read. So rather than using the star, let's just pick the columns that we're interested in seeing. This is the exact same query as the previous example, but rather than using the star, we listed the columns that we wanted to see. Also, I changed the format of the statement so that the clauses are on separate lines to make it easier to read. As your queries become more complex, it becomes very difficult to keep your statements at 80 characters or less, so it's helpful to break it up into separate lines. So this is becoming a more useful query. But it would be even more useful if we could have a table that showed a list of songs that also included the genre names, the artist names, and the album names, so we wouldn't need to look them up separately in different tables. This is where we run into a little challenge. Whoever set up this database decided to use the column header called name in the artist table, the genre table, and the track table, but they've referred to different names. When setting up a new database, you should avoid using column headers that will conflict with column headers in different tables. Here, the column header called name will lead to confusion if you're trying to join these tables. Fortunately, in SQLite, you can use an alias when selecting columns to avoid this confusion. By using the as keyword, you can assign a temporary name to the column. This will not alter your database. The alias will only be used for your query. As you can see in this example, we have successfully joined the track table, the genre table, the artist table, and the album table into a single table. So now we have a list containing all of our songs with all of the relevant information in one place. Pretty nice, huh? Go ahead and save your SQL file. In the next section, we'll explore some of the options that you have for exporting this data so that you can use it in your projects. Databases are great for collecting, storing, and maintaining data, but it can be challenging to perform analysis from directly within a database. As a result, many people query the data that they're interested in, and then they export that data so they can do something interesting with it somewhere else. In this section, I'm going to show you how you can extract your SQLite query data into various file formats that you can save onto your hard drive. I'm also going to show you how you can load that data directly into memory so that you can use it with your Julia projects without having to save anything onto disk. The easiest way for you to extract your query data is by using the SQLite extension. Click on the Export CSV button to export your data as a CSV file. Click on the Export HTML button to export your data as an HTML file. Click on the Export JSON button to export your data as a JSON file. You can view your CSV file from VS Code by using a VS Code extension. There are several CSV viewer extensions available, so just use whichever one you like. Likewise, you can view your HTML file from VS Code by using a VS Code extension, or you can open it up using your favorite web browser. Here's how the data looks inside a Firefox browser. You can reformat your HTML file by right-clicking in the document and by selecting Format Document. The JSON file format is not really for viewing, but it may be useful if you're using a web app or some other application that requires data in the JSON file format. Like the HTML file, you can reformat the JSON file by right-clicking in the document and by selecting Format Document. None of these documents are large files, but you may want to avoid saving files onto your hard drive if you don't really need them. You'll be happy to learn that you can load your query data directly into memory by using Julia. In your tutorial folder, create a new file called music.jl. Launch the Julia REPL by using Alt-J, then Alt-O. Maximize the terminal panel. Change the present working directory to your tutorial directory. Enter the package REPL by hitting the closing square bracket. Activate your tutorial directory. Add the following packages: type in status to confirm the version numbers for your packages. Exit the package REPL by hitting backspace. Minimize the terminal panel. All we're going to do is use the SQLite.jl package, and then copy and paste our query statement from our .sql file into our .jl file. Be sure to paste your query statement inside quotation marks. Last week, we used the sqlite.execute function to execute SQLite commands. SQLite.execute is a low-level method that simply executes SQL statements, but it doesn't actually retrieve any data from the database. dbinterface.execute is a higher-level method that retrieves data from the database in addition to executing the SQL statement. Okay, now that your query data has been loaded into memory, you can load it into a Julia table. Now that your data is in a Julia table, you can load it into any Julia constructor that supports the tables.jl table format. Let's start by taking a look at our data using VS Code Display. So that looks pretty good. We can also load our data into a pretty table using the Pretty Tables package. You can also load the table into a data frame using the Data Frames package. Finally, you can convert the data frame into a Julia array. Once you have your data inside a Julia array, you can do all sorts of interesting things with it. Note that when you convert a data frame into an array, it leaves off the header row. In my case, this is what I want, but it may or may not be what you want depending on what you're planning on doing with your data. Viewing the data inside the Julia REPL is difficult. Personally, I like using VS Code Display to view my data, but you need to be inside VS Code to use it. It would be nice if we had a GUI that was similar to VS Code Display, but would work outside of VS Code so that we could launch it from the REPL or from any other programming environment. Now that we know how to use both SQLite and GTK, let's try to create our own custom data viewing GUI using the GTK package so that we can view our SQLite data outside of VS Code. For this project, we're going to create a custom data viewing GUI called Doggo Display, which is inspired by VS Code Display. Save your files, but keep all of your files open. Close out of your Julia session by hitting Ctrl-D. In your tutorial folder, create a new file called doggodisplay.jl. Launch the Julia REPL by using Alt-J, then Alt-O. Change the present working directory to your tutorial directory. Enter the package REPL by hitting the closing square bracket. Activate your tutorial directory. Exit the package REPL by hitting backspace. The first thing we're going to do is to copy the first 23 lines of the music.jl file and paste it into the doggodisplay.jl file. Next, we need to convert the query data into a Julia array. Now that we have our query data loaded into a Julia array, we can get started with GTK. Next, we need to create a GTK list store which will contain all of our data. Our display will have 5 columns. The first column will contain integers showing the track ID. The rest of the columns will be strings, showing the genre, artist, album, and track names. When constructing a list store in GTK, you need to enter each row of data as a tuple, which is why we're converting each row of the array into a tuple here. This for loop will go through each row of data and then push that data into the GTK list store. Next, we need to tell GTK how to render our list store and what column header names to use. By the way, all of this code is in the gtk.jl documentation, which is why I'm going through it fairly quickly. Next, we need to create the GUI window. You should see a blank GUI window appear. GTK scrolled window is a layout option that I didn't see in the gtk.jl documentation. As its name suggests, it installs scroll bars in the window so that you can scroll up and down as well as side to side. Using this GTK scrolled window is required if you want to display large datasets. Now, let's see what our new GUI looks like with our new layout and with our data. Your GUI should now contain all the query data. Pretty cool, right?
Bruh.
Try resizing your window. Now, try clicking in your dataset. It looks like you can click on a row, but it doesn't look like you can change the columns or sort the columns. We can add some lines of code to add these features to our display. Again, all of this code comes directly from the gtk.jl documentation. Now, you should be able to resize the columns. And you should be able to sort the columns. And you should be able to reorder the columns. Pretty cool, right?
Bruh.
This demonstration is using query data pulled from a SQLite database and loaded into a GTK GUI without needing to export or import any external files. Of course, you can use this display with data from any source as long as you can load that data into a Julia array. But it's nice to know that you can plug in directly into a database without having to worry about exporting or importing external files. In today's tutorial, we learned the basics of performing queries in SQLite by using the Chinook database. We also learned how to export our query data out of SQLite and into various file formats that we could save onto our hard drive. In addition, we learned how to export our query data into memory so that we could use it with our Julia projects. Finally, we created a custom GUI using the gtk.jl package that displayed our data from SQLite, which demonstrated how we can use different Julia packages to create an interesting project. There's a lot more to learn about using SQLite, but hopefully these past 2 videos have provided you with enough foundational material for you to feel confident to pursue the subject further on your own. Before leaving the subject behind, please remember to go to the GitHub repository for the SQLite.jl package and leave a star. Well, that's all for today. If you made it this far, congratulations! If you enjoyed this video and you feel like you learned something new, please give it a thumbs up. For more wholesome Julia tutorials, please be sure to subscribe and hit that bell. If you like what I do, then please consider joining and becoming a channel member. New tutorials are posted on Sundays/Mondays. Thanks for watching, and I'll see you in the next video.
Bruh.